Welcome everyone to another National Graphene Association video interview. Today I'm joined by Charles Chang from TLC Products, and we're talking today about graphene in polymer resin composites. Now, for those who don't know Charles, he is from the polymer resin industry and has made the transition over to making polymer graphene composites, so he's the ideal person to talk about today's topic. So seeing as we're discussing graphene in plastic composites today, it's probably best if we start at the beginning. It's a long-standing industry. And how big is the polymer composite market, and what can be done to innovate such a long-standing industry? Charles?
Sure. Plastics can be classified into three groups: the general plastics, engineering plastics, and composites. The general plastics includes HDPE, PP, PS, PVC, and so on. The volume is huge. They have one common weakness, which is they are not rigid enough. So the second group is engineering plastics. They include nylon, PC, ABS, PEEK, and they are much more rigid and stronger. The third group is composites. This is an interesting category of plastics. It combines an additive with plastic material to make it much more rigid and stronger material. Over the years, many additives have been introduced and created successful composite materials. Today, the estimated sales of composite is 85 billion a year in 2018.
Okay, well, thank you. So what different types of plastic composites are commonly used today, and what are the advantages and disadvantages of these composites?
The most popular composite really is glass fiber composite, and it has been around more than 50 years. The annual sales is around $45 billion. It can be combined with many resins to make them more rigid and stronger than expensive engineering resin. Glass fiber costs about 50 cents a pound. So it makes glass fiber composite cost competitive, hence found many applications in the marketplace. However, glass is heavy, so they are used in areas where weight is not an issue, such as bicycles, boat, building, and so on. Carbon fiber is a newer material for composites. It is lightweight and strong. It is used on Boeing 787 airplane to replace its metal body. And the popularity of carbon fiber composite has grown substantially over the last 15 years. Annual sales is around $19 billion a year. Carbon fiber costs around $20 a pound. This makes it an expensive composite.
Okay, so it's been stated that graphene could be used in plastic composites and fill the gap between the main two types of glass fiber and carbon fiber. What advantages does graphene bring to polymer composites, and how can it help to bridge the cost and performance gap of the other two main types?
Yeah, graphene is the newest material for plastic composites. It is 200 times stronger than the steel, yet is lightweight. Graphene composites are lighter than glass fiber composite, and it has just started being used in the composite industry. The annual sales is around $60 million.
Okay, So I've heard about the obviously the benefits of graphene. Are there any current challenges with using any of the different types of graphene in polymer composites?
The current challenge is cost. Graphene flakes cost similar to or even more expensive than the cost of carbon fiber. So the worldwide capacity also is around 4,000 tons a year. The quality of graphene flakes vary from lot to lot and manufacturer to manufacturer. This makes it difficult to apply graphene in the composite industry.
Okay, so I've heard that you have a solution for overcoming these challenges and can now make graphene polymer composites that are economically feasible.
Yeah, TLC Products has an exclusive license on a technology invented at Rutgers University, led by Professor Tom Nosker. Rutgers has received patents from US, EU, Japan, China, and other countries. Our mission is to develop a commercial process to produce high-quality graphene composites economically.
Okay, and what are the main advantages of your methods for making these composites over other approaches? And how do you think this method could help to realize large-scale production of graphene polymer composites?
The main advantage of Rutgers technology is that it uses graphite as raw material. Okay. It mixes graphite directly with resin to produce graphene composites. It does not use expensive graphene flakes. So this eliminates many challenges currently associated with using graphene flakes, such as cost, quality, capacity, and so on.
Okay, so if it will soon be possible to make graphene polymer composites at an attractive price point, what applications and market sectors could be revolutionized by these graphene composite materials?
Transportation is a good category. This includes airplanes, automobiles, buses, rail cars. For example, EV, electric vehicle, is the future of cars. Lightweight is a necessity. Graphene composite can provide the low-cost, strong, lightweight to substitute the metal used in the cars. And sporting goods is another category, household goods, construction material, and all products currently made with plastics can be benefited.
Okay, so how long do you think it will be before we start to see graphene polymer composites being used on a wide scale compared to, say, carbon fiber and glass fiber composites?
TLC has developed a production machine to make graphene composite 2 tons a day. And
Okay.
we will receive this machine in October 2020. This is a continuous process, can be scaled up quickly. So we'll see initial applications in 2021 and a wide use in 2022, 2023. Eventually, it'll become part of our daily life everywhere.
Okay, so a lot to look forward to there then. And finally, a question that I ask everyone regardless of the area. What impact do you see graphene, and in this case graphene composites, having in society, and what's going to be some of the key areas to look out for in the future?
Graphene composite makes plastic material more rigid and stronger. So this way, it will enable the industry to lightweight and use less plastic material on products they are making. We estimate a material reduction about 20 to 40% that is achievable. This means lower carbon footprint and less environmental pollution. Graphene composite can make this world a better place to live.
Okay, brilliant. All right, well, thank you, Charles, for coming and bringing your knowledge and expertise and about what's to come as well for the future of TLC products to the NGA interview today. It's been real nice to chat to you, and I hope everyone watching has got some good insights as well. So it's been Charles Chang from TLC Products. I've been Liam Critchley from the NGA, and until the next NGA video series, goodbye.